Hey everybody, it's Mr. Patron, and in this video, you're going to learn about something called the Lewis dot diagram, and it's going to help us make sketching out some atomic structures a bit easier from what we've been doing. So I'm going to share my screen, and I have a set of notes set up. So we're going to just kind of roll through these, work through this material. And this will kind of help you going forward. So once again, today we are going to be talking about Lewis dot diagrams. So a Lewis dot diagram is an image or a sketch, a model that's used to describe the valence electrons and their presence in the atom. So we use these because the valence electrons are the ones that deal with chemical reactivity and chemical reactions in general. The kernel electrons, the ones that are in the inside rings, are not really that useful to us. They're not really that important in chemical reactions. So we're focusing solely on these valence electrons. The guy who designed this, his name is Gilbert Lewis. He was a chemist. He has some other things that he did in chemical work. He didn't just make these little sketches. He also did a lot of work with acids and bases. If you take AP chemistry or college chem, you'll learn a bit more about Lewis acids and bases, and that derives from him. That's him right there. All right. So let's start talking about what these are and like how to sketch them. All right. So there's three main steps as to how to sketch a Lewis dot diagram. I'm just going to annotate this here, make sure my pen is set. Cool, good. All right. So first thing we want to do is identify the number of valence electrons that are in the atom. Pen isn't working right now. There we go. I had it backwards. Okay. So let's say we're going to make one of these diagrams for oxygen. So if you go to the periodic table, oxygen is atomic number 8. And it has the electron configuration of 2-6. It is also in group 16. So that's another way to indicate that it's going to have 6 valence electrons. So I'm just going to note that here. 6 valence electrons. So now that we've determined that, we're going to write out the symbol for oxygen, which is just O. So O. And then we're going to place a dot on top of the element symbol, and that is going to represent one of the valence electrons. So I'm just going to put the dot up here. I'll put a dot up top here. And this represents one of the valence electrons. And we're starting from the top here. Now, we're going to go in a clockwise fashion. So like if you open at a clock, we have 12, 6, 3, 9. It's going to go this way. So in a clockwise fashion, we're going to add one dot to each side of the element symbol in kind of like quadrants. So if it might help, maybe you can draw some lines along this. Say like each of the 4 sides of this. I'm going to erase those, but there might be something you want to that might help you. Once again, we're going to draw one dot on each side of the symbol until we've reached the number of valence electrons necessary. So we've got 1 here, 2, 3, 4. Now we're not done. We've only gotten 4 electrons so far. So we're going to start doubling up. So once you hit all 4 sides, then you can start back at the top and add a second one. So 5 and 6. And this is it. So the Lewis dot diagram just has the symbol and the valence electrons dispersed in a particular order. 1 on each side until we run out of sides, and then we can start to double up. So it is pretty straightforward and a lot easier. It doesn't necessitate it's not necessary, I'm sorry, for us to draw all those inner electrons. So let's go through one more. So I'm going to clear this. Oh, there we go. So why don't you try sketching a Lewis dot diagram of chlorine? Pause the video, sketch it out, see how you do. Okay, so we'll just roll through this together. So chlorine, I'm going to write its symbol, Cl. And then we know chlorine is atomic number 17. It is in group 17 and has the electron configuration of 2, 8, 7. So 2 indicators that we have 7 valence electrons. So once again, we'll start at the top, 1, and then go clockwise, 2, 3, 4, and then start doubling up, 5, 6, 7. So we have our symbol, we have the 7 valence electrons circled around it, and this is all we need to know. So now we're going to take a look at how we do this for ions. So ions are going to have a slight difference. So as of this point, we know what a cation is, a positive ion, and an anion, a negatively charged one. So we're going to clear this. I'm going to just jump to that. So in terms of ions, so either positive or negative charged ions, we use brackets, and that allows us to indicate that there is a charge. And this is a common thing in chemistry when we're writing out particles that have charge. Oftentimes a bracket will be shown. So a bracket like this is kind of like the squared parentheses. Something we haven't seen yet. And really, we only use it for this topic, but we may see them. You may see them later on if you go and study more chemistry. Now, since we're dealing with metals and nonmetals and they're either gaining or losing electrons, each Lewis diagram is going to have the same number of electrons shown, depending if it's a nonmetal or a metal. So hopefully you recall that the nonmetal atoms, they gain electrons in order to form their negatively charged anions. So since these are gaining electrons, their Lewis diagrams are going to indicate that there are 8 valence electrons. So no matter how many it starts with, our end goal is to have 8. So all the Lewis diagrams should have 8 valence electrons. For the metal cations, those are the ones who lose their electrons, they show that there are 0 valence electrons. So once again, they've been lost, so no valence electrons will be shown. Outside of this, the charge is also shown towards the top right of the bracket. So I'm going through an example of each a metal and a nonmetal. So a metal cation would be sodium. So Na originally has the electron configuration of 2, 8, 1. So it has 1 valence electron, which it wants to lose. So if we were to draw the Bohr model, we would have 2 rings here. I'm sorry, 2 electrons there. 8 electrons here. Imagine that was on the line. And then that 1 valence electron has been lost. But for these Lewis diagrams, we don't need to do that. We're just going to simply write out Na, put it in the brackets. And because the Lewis diagram of metals is indicating the loss of electrons, we don't have to draw any dots. You're just going to put a charge on the outside. So you could put plus, or you can even put +1 if you prefer. Either is acceptable. Now for a nonmetal, such as, let's go back to oxygen. Oops, spelled wrong. So oxygen has a configuration again of 2-6, so 6 electrons in that valence shell. So in order to achieve a noble gas configuration, it's going to gain 2 more. So there's note here, sodium lost 1, where oxygen is going to gain 2. So to indicate this, we'll once again draw the element symbol oxygen, O, in the brackets now. And then we're going to put our 8 valence electrons around it because we have gained 2 from our original 6. So 1, 2, 3, 4, 5, 6, 7, and 8. So there are 8 electrons in this last shell now, and it will have a -2 charge. So once again, the nonmetal has 8 electrons around it, and the charge, negative charge, is on the outside here. The next slide is going to ask you to sketch out a couple on your own. So why don't you do that? Pause the video, and then we'll check on it in a bit. So once again, I want you to check out sketching a calcium ion and fluoride ion. Okay, so let's just roll through what the calcium ion would look like. So calcium has the symbol Ca. It is a metal, so it's on the left side of the periodic table. It's going to be in group 2. So it has 2 valence electrons to begin with. Throw in the brackets. And because we are losing both of those valence electrons, calcium will have a +2 charge. You may also see the charge written as 2+. There are some rules that we don't really follow in this class, like depending on where the positive falls in the front or the end. And once again, it's kind of whatever you like. So if you prefer writing +2 like so, or if you want to write 2+, I am fine with either. Okay. And then for fluoride, so you may remember from class that the ending of the nonmetals when they turn into an ion goes to IDE. So fluoride comes from fluorine, which has the configuration of 2-7. Because it's in group 17, has 7 valence electrons. Fluorine is going to gain 1 more electron in order to appear like the noble gas neon. So to sketch its Lewis diagram, put the F in brackets, and then we sketch our 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, and 8. And because we started with 7, we added 1 more. Fluoride has a -1 charge. Once again, you could just put the negative there, kind of like in math. X is equal to 1x. Here, a negative is equivalent to -1. Okay, so hopefully this was a helpful video. We'll be using this fairly frequently, so be sure to get familiar with them. Complete the independent practice just for some more experience with this, and we'll start using these a bit more this week. Bye everyone, have a good one.